Hello, good morning, and welcome everyone to our session on user experience on ontology engineering tools. So today, before we start, just I will mention some housekeeping things. Like during the talks, your micros and camera are automatically deactivated. So, and after the talk, the discussion will start, and you can, during the talk, include your questions in the Q&A tab, leaving the chat for other comments. And after the session, you can also raise your hand if you want to ask a question, opening your mic, and then you will be invited to the stage. And yes, please use the session feed for chat and the question and answering function only for the questions. So today we will be focusing on the user experience on ontology engineering tools, and how we will. The goal of this session is to improve the intra and cross-domain interoperability between the industrial domain ontologies, and how we can get that with the support of the tools and methodologies to reach this harmonization. Today we will have 3 talks from experts in this topic, and let's just start with our first speaker, Enrico Motta, who will be talking about human-computer interaction for ontologies. Enrico is a professor of knowledge technologies at the Knowledge Media Institute at the UK Open University, and he also collaborates and works for the Department of Information Science and Media Studies of the Bergen University in Norway. He has led dozens of research projects in several programs, like European and also nationals, and not only in UK but in other countries. And also he has authored more than 350 reference publications. So hope you enjoy Enrico's talk about HCI for ontologies. Enrico, can you share your screen? Well, I had to summarize your bio.
Okay.
To keep it on time. Sorry.
Yeah. So, can you see the slides in full screen format?
Yes, perfect. Thank you.
Okay, excellent. So, yeah, thank you very much for the introduction. So, just a reminder, I'm using PowerPoint directly, so I'm not seeing the mid screen. So, if things happen in the chat, I won't see them. So, please alert me. So thank you very much for the invitation. Normally I give presentations about stuff that I'm kind of doing now or I plan to do. This will be quite interesting because this is I will be talking about stuff that I did about 10 years ago. But from conversations with Marìa Ken at the previous workshop, we thought about it would be interesting to talk about HCI for ontologies, the state of the art. And the point is, I guess, is the state of the art has not dramatically improved, if it has improved at all in the past 10 years. So let me see what I'm talking about. So back in 1996, there was this quite influential paper on information visualization from Ben Schneiderman. And basically, the sort of very useful thing that Ben did was to sort of list the seven things that any information visualization system should be able to support. He calls this functionality this kind of task. And of course, if you talk about an ontology engineering tool, of course, information visualization is a key element. Of course, there is also the reasoning element, but by and large, a lot of the time with ontology editors is spent building ontologies or very often making sense of ontologies that already exist. So basically what Ben Schneiderman talks about is, say, well, you need to have, functionalities that allow you quickly to see the overview, the entire collection at the sort of abstracting from details, but then you have to be able to zoom in or zoom out of what you are interested in. You have to be able to remove stuff that is not relevant. Of course, you need to have a good history mapping so that you go forward, backward, etc. So I won't describe these things in detail, but essentially you get the knack. I mean, there are certain things like providing abstraction, providing ability of zooming in, providing ability to rule out, remove information, and also home in on detailed information, which is obviously quite important for any information visualization system, in particular ontologies. So, so just to give an example that I'm sure everybody will be familiar with, if you look at, for example, a map of Europe, these maps actually work pretty well. In a very concise way, I can basically see every single country in Europe. Of course, I can see the size of the countries, so I can see which countries are bigger, which countries are smaller. I can also see the relations between different countries, for example, in particular, neighborhood. And indeed, for example, like in this one, there is also the nice bonus that I can see the capital city and also some of the main cities. So essentially, the point is that people draw maps seems to be able to convey a lot of very useful information in a very concise form. And then, of course, you can, for example, zoom in on Sicily, and then you see, the small cities in Sicily, the big cities in Sicily, the communication in Sicily, etc. Now, let's move from geographical maps to ontologies. And then you see, so I'm using the screen snapshot from Protégé displaying the Sumo ontology, which is one of these top-level ontologies. Indeed, this is is a slightly modified Sumo, which has removed a lot of the clutter. So it's an incredibly clean version of Sumo from the purpose of browsing. And of course, it's quite nice. On the left-hand side, you get the subclass hierarchy, you get the classes. You also have this ontograph that allows you to visualize graphically. But I mean, if you compare it to the geographical maps, there are some obvious limitations. So, for example, like it doesn't tell me the size of subtrees in contrast with the geographical map. So I have no idea whether, for example, the physical class, for example, the agent class, which I haven't opened, is going to open. If I open, is going to produce 150 classes or one. The only relation that is easy to browse is subclass of. Although there are here in the graphic, in theory you can use other relations. The support is really not very, very good. Of course, again, in contrast with geographical map, you can see important nodes because everything is in a top-down way, and basically any node, whether it's important or not important, will be open if I click on one of these classes. Also, there is no history mechanism in the sense of opening up a new page and then going back like in a browser. And there is no, let me go back here. And there is no way in which you can actually customize this. Everything is very mechanical. Either I open a node or I close the node. Either I add the node to the interface, the graphic interface. I don't. There's very little customization. And of course, that one was a particularly clean one. If I look for example, schema.org, and I want to focus on the core of schema.org, that is creative work, event, intangible. I still get all this rubbish from other ontologies that are relevant, but I don't really want to explore them. But for example, again, Protégé doesn't give me any facility to hide, so violating one of Schneiderman rules. And of course, I don't want to sound too critical of Protégé, because to be honest, the same problems, for example, I have with TopRed and more or less with any ontology engineering tool that I know of. So, so very quickly, I want to tell you just something that can be done, or that we have done in the past to try and address these kind of problems. So, for example, about over 10 years ago, we worked, for example, on summarization algorithms, something called KCE, key concept extraction. And the idea is basically, you have a big ontology like this one, which was the old AKT ontology, which talks about essentially academic life, and anybody who knows this ontology, will be able to say, well, yeah, this ontology is about academic life, it's about project, researchers, technology, publications, events, etc. So why don't we do the same thing with our ontology engineering tools as a way of abstracting from the hundreds, sometimes thousands of concepts which are in an ontology? So basically, well, I'll skip the details of how we do ontology summarization, but essentially, the idea is that then, for example, you can use these methods to, for example, to provide abstractions of an ontology. So, for example, this is a tool called KCVs that we built about 10 years ago. And for example, we can generate from the top node entity in the sum ontology a 15 classes, again, completely under control, summary of the ontology, which does not just opens up the subclass or entity, but tries to identify important concepts in the ontology. And then, for example, again, let me skip this one. So, for example, if I want to explore in more detail a particular subtree, for example, the subtree of class relation, as you can see, I get a menu which gives me a lot more control. I can decide whether I use the key concepts to summarize the. Well, first of all, it tells me basic information about size. There are 14 direct subclasses, 42 subclasses in total. So if I expand to all levels, I will get a tree with 42 subclasses. So I don't want to do that. I just say, well, give me just the most important concept, only focus on subclasses, and hide other concepts. This essentially remove anything else from the display, open a new page, and then I get something like this. And the other thing, of course, as I said, instead of having subclasses and superclasses only, it's actually very useful sometimes also to see, for example, domain and range relations. And again, with KCVs, I could do that, open up a different kind of visualization, and again, see, for example, the relation between physical, the class physical, and other classes. So again, of course, this is quite old tool, and I'm not saying necessarily that it solves all the problem. But the thing here is that there was an attempt to try and get a little bit more control over the navigation process and the browsing process than what is provided by today's tools. And indeed, in formal evaluations, we showed that KCVs perform much better on sense-making tasks compared to every other tool that was available at the time. Okay, I'll just, it's only a 10-minute slot. I think I'm just about to go over. So just to conclude, the main message is HCI for ontologies, like HCI for any big data space, is very important. Certainly, my feeling is that there's not been as much progress in the past 10 years as there should have been. So this is really, for those of you who have an interest at the intersection of knowledge engineering, ontology engineering, and HCI, I think there are very, very interesting PhDs and very, very interesting master projects that can be done. And I think this is a good way to finish. Thank you.
Thank you very much, Enrico, for your presentation and the knowledge from many years you share with us, and also for being so aware of the time that you also have some seconds left.
Thank you.
So
it's very unusual for me.
I would like to open the floor if there is any question from the audience. I don't see any in the Q&A, and I don't see the hands raised, but yeah, here. Let me see. Okay, and well, maybe in the meantime, while people start writing their questions or raising their hands, I would like to ask you some questions, because I'm really interested in this topic. Okay, we have one from Gerald. Are there any commercial tools for HCI? You see that in this?
I guess, yeah, because I guess you mean HCI for ontology engineering. Well, the commercial tools that I know of are the ontology engineering environments. In a sense, I think there are fewer ontology engineering environments now than there were 10 years ago when we were doing this research. To my knowledge, the most comprehensive one is commercial one is Top Grade by Top Quadrant. But again, as I pointed out, I think the HCI element is rather limited, although they have a very, very strong support in terms of functionalities, supporting constraint languages like Shackle, and also providing a rich development environment for developing applications. And I have no shares in Top Quadrant.
So Gerard also asked whether there is no market for this kind of tools.
So is that the question?
Yes.
Well, that's yeah. That's. Sorry. Yeah, that's a very good point. Clearly, there is much more of a market for the developer side than the user side. Although having said so, there are companies, for example, like Grapho, who are now investing, some significant resources in providing online collaborative ontology editors, and of course, in that particular context, the HCI element is crucial. So I guess if you talk to Juan Segueda at Grapho, he will tell you that there is a market. While maybe if you talk to the people at Top Quadrant, they say, well, there is no point in wasting too much time on the user interface because they sell to developers. Okay, there is another question. Do you think the lack of focus on HCI for ontology is one reason for its limited uptake by industry? Certainly, I don't think it helps. It is the tools that we have at the moment are very painful. They introduce a certain barrier, and that cannot help. Even less in industry, because of course, if you're a PhD student, so you're prepared to suffer because you have a big goal of a PhD. If you're in industry, you're always evaluating the efficiency element. If there are other technologies similar to ontologies in other domains that provide better tools, then you're not going to use ontologies. Or certainly you're not going to use our version of ontologies.
Thanks. There is one question from Lan. Yeah, that one. Do you think ontology engineering tools are necessary to be collaborative?
Yeah, again, I think it helps. It helps big time, and that's I understand. For example, is the key focus of Grapho. They are really focusing on having an online tool that allows teams of ontology engineers to work together. And of course, there is also a collaborative protege. Yeah, I think the collaboration is important, but at the same time, if you don't get the basic right, you can put all the collaboration in the work. I mean, if you have an interface which is pretty rubbish for a single user, I would say it is very unlikely that it will work very well for a team of 10 ontology engineers and domain experts.
Thanks. And if you think we can take the last question from Sanju Tiwari before moving to the next presentation. Which tool are more reliable offline, like Ontograph or web app like WebOwl?
Well, if you're talking about offline, well, I mean, Protege with Ontograph is very reliable. I think it's been used for a number of years. I never encountered major problems. Of course, TopRaid is also very, very, very robust environment. However, they no longer support OWL, which I think is a statement in itself. Consider that they are the biggest, well, say the best known industrial company focusing on this area. So that means that if you have an OWL ontology, you have to massage it and translate it into other formats if you want to use it with TopRaid.
So thank you very much, Enrico. And we can still have some more questions at the end for the open discussion. And then let's move to our next speaker.
Thank you.
I will thank you. Felix Engel, who is a researcher with more than 10 years of experience in academy and currently employed at the TIFF in Hanover. And also very active in the community regarding publication records, attending conferences, reviewing, being chair of conferences and journals. So Felix will give us a presentation about terminology services for community-driven ontology development. Hope you enjoy the presentation from Felix. The floor is yours.
Okay, thanks. I hope that you can hear me well and that you can see my presentation. Okay, perfect. That's really good. Okay, yeah, hello, many thanks for inviting me. So my talk is about terminology services for community-driven ontology development. And actually, I would like to, here we go. I would start with a short motivation on our work. So we have encountered in Germany, but this holds true for Europe and I guess globally, that research data is of inestimable value because it empowers researchers to create innovative new work to advance our knowledge and so forth. Essentially, new and innovative research should rely on existing research. So existing research should be transparent and reproducible in order to foster its reusability. However, we see the situation, and that's is not only true for Germany, the data is stored decentrally, stored temporarily with varied quality, and we have a problem of non-standardized metadata. And that's why we have a huge, a big initiative in Germany, Nationale Forschungsdateninfrastruktur, that addresses exactly this need. And what they does if they fund various projects with a community specific focus. So we have projects within the biodiversity domain, in the chemistry, the cultural domain, within health, and within the engineering domain. Because they all have various very specific needs in terms of data management. And we at TIP are involved in some of those projects, and we are, or my work in this project is to enhance user experience by terminology standardizations, by providing tools that support users to this respect. So actually, I would like to introduce or to just rephrase some key aspects that I think are very important to this respect. So terminologies are totally domain specific. So every domain will have their own terminology and their use of terminology. And even within a domain, a terminology could be community specific. So a community could make use of the terminology in a totally different way related to another community in the same domain. However, the work on terminologies is a very dynamic work. Terminologies evolving over the time, and there will not be a point in time where one would say, now this work on the terminology is done. So essentially, it is very important to see that terminologies must be well accepted by the community, because this will foster its continuous development and maintenance. And this essentially will avoid to produce isolated solutions. And therefore, we need kind of a mechanism that brings terminologies or ontologies into the communities into the communities, yeah, to promote them and to make the community aware of its existence. We need to align it with other community efforts, and we need in our task to make them applicable in research data management in practice. So we at TIB support this with a terminology service for ontologies, which is a quite known concept in the medical domain. But if you have a look into the engineering domain and in others, you will see that this is not a common approach. And in general, a terminology service is a web-based platform that supports take-up and standardization efforts of terminologies, and in our case, ontologies. And such a service offer is used as an entry point to prepare research data for its later usage or reuse. For instance, according to a data management plan, as for instance, to tag or index your research data if you upload it into a repository for later reuse. You should use for sure a consolidated terminology, one that the community is able to understand, and this will for sure support later reuse because the search will be supported by by the usage of a consolidated terminology. And the terminology service as well is served as a community hub to foster awareness and the alignment of ontologies, because it is kind of a one-stop for ontologies of a specific community. It bundles them, it provides metadata and statistics, and it allows search within ontologies and make those alignments visible. So essentially, what we have or what we work on is a central terminology service that holds all ontologies from various domains. As for instance, at the time from the engineering domain and from the chemistry domain. And we have as you see on the right hand side, we have domain specific instantiations that are referenced to our central installation, but provide just a focus view on such a domain. Okay, we have released this year in July. We have the central service. This is a screenshot of the service. And we hold 46 ontologies across these two domains, so engineering domain and chemistry domain. And we allow to do free text search across those ontologies, and within those ontologies, we allow browsing, filtering, and the visualization. We have introduced an issue checker because this is, a community effort. So everyone is more than invited to have a look at this service and to propose new and important, relevant ontologies that we will integrate in our service offer. And next, we have or we provide a REST-based interface that allows machines to automatically query our service to really kind of make use of those ontologies that we have indexed and to bring them into the application. This is a view on, so this was our central installation. This is a view on the engineering terminology service. So here, as you can see, we have fewer ontologies, and 25 ontologies are in here, and we offer the same service as I have introduced in the slide before. Here are two screenshots that show the search functionality. So that on the left-hand side, that allows you to search and to filter your search after a given criteria. And on the right-hand side, you see the browsing functionality that shows you all of the available ontologies sorted alphanumerically. Here, I have listed two projects that already make use of the service. There is the Semantically Connected Semiconductor Supply Chain project, which is a CSA project from the Commission, and they are working on a digital reference ontology that we host in our terminology service and make them available for the community. And what I would like to show here is that, for instance, if you search for a system, a concept system, which is available in the digital reference ontology, you can as well see that the same concept is available in a different ontology, which essentially is the sensor network ontology, and so forth. So we do a bit of alignment here as well. We are starting on this task as well. And the next project is the AIM project. They work on the creation of application profiles, which are kind of very individual metadata profiles that are commonly used by a researcher. Yeah, and they query our terminology service to populate their application profiles. This is a bit of road mapping. Yeah, let's say what we would like to add, and we are quite far with this work, is to classify all the ontologies that we have indexed. For instance, if they are top level ontology or domain ontology, but we as well would like to index their context, their content, like what are the main subjects of this ontologies and so forth. We as well think about the provision of trust measures, because if you as a decision maker who wants to or are in need to decide on an ontology for your work, you may need some indicators, as for instance, is this ontology actively in use? Is it curated? Is it maintained? So, or will it be dead in the near future? So, to provide measures to this respect. As well as the usage itself. So, for instance, how many REST queries do we have on this ontology, and so forth. We would add collaborative work functionality to our service. We need to work on visualizations, and we have plenty ideas. We are quite creative on this topic, and that's it. Thanks.
Thank you, Felix, very much for your presentation. And I have to admit that it is very informative, and there was a lot of data for me. So I'm still processing. Let's see the question and answering. So why not use an existing open source terminology service such as OntoPortal or Ontology Lookup service?
Mm-hmm. Well, yeah, we actually use the ontology lookup service. This is the base software product that we have built our service on, and we kind of are in exchange with EBI about it and our progress. We would like to, as a community effort as well, we would like to provide them our new features for integration into their lookup service as well. So yes, that's what we are doing already. Yeah.
Thanks. So now there is a question from John Breslin. You see that? Right?
Yes. Any plans for shared ontology and other any plans for shared? Yes, for sure. Yeah, as I said, many thanks for this question. I mean, I would like to, if this service is getting more popular, and that that the community is actively engaged in this and propose new ontologies that we could include in our service, and in more features that are required or seems to be valuable for the community. So we are happy if we can get in contact, and we would love to share more ontologies on our service.
Okay, so now there are a lot of questions, and I hope for this one, the one on the screen, we have a quick answer, and we don't enter a never-ending debate.
Okay, good, great. Good to see that this is an active discussion topic. Great. How do you define it? Okay. Yes, we define ontologies as those that are that rely on the semantic web stack. So RDF, OWL, and so forth. So we are able to integrate every format like turtle, and triple, and so forth. So, but to answer this question more concretely, yes, we are focused on ontologies that are represented through the semantic web stack. I hope that answers your question.
Okay, thank you very much, Felix. And I think we will stop here the questions and save the rest for the discussion. So thanks for your presentation and sharing with us the service. And now let's move to our last but not least presentation that will be provided by Arild Waaler. And sorry here if I pronounce everything really badly. Arild is the director of the Sirius Center for Research, Based Innovation, and professor in the computer science at the University of Oslo. In addition to this center, Arild is also very engaged in the Equinor-led initiative targeting the transformation of technical documentation from the document format to structured asset information. And then the talk is going to be exactly about the experiences from this project work and how it is entitled. It is Ontology Engineering Tools for Heavy Industry. There is no such a thing. Thank you. Arild, the floor is yours.
Yes, thank you. So, yeah, ask the usual question. You see my screen and it's working? Perfect. Yes, so I will give a little report from an ongoing industry project, which is a large capital project driven by the oil and gas operator Equinor. And they are building a facility, and it's now in the so-called FEED phase, the front-end engineering and design phase. And what I'm going to show is related to the efforts of building an information model, where the ambition is to use principles and methods and tools enabled by ontologies, and by this way of structuring the information in a very precise, transparent way. I will talk about the approach, and that can give a partial answer to the question, what does it take for industry uptake of ontologies, and in that way very relevant for ontology engineering. But my title is also reflects that we found no tools and methods that we could just use. So Equinor started a non-editor project, which will be open sourced next year and possible for researchers to join. And I'll show some screenshots from that. This is an editor that is in use as we speak, and the user experience reports from this is so far encouraging. But basically this is about principles, and yeah. So I made some quick slides. So first, what do I mean by heavy industry? And I think my point is that there is a project with a client with a need for something which hasn't been built before, and there are a lot of equipment, a lot of suppliers going into, and in that, when you talk to suppliers, then you are in a world of product types and a regime where ontologies have been used with large success in some situations. But in this project, you have a very large layer in between, which is the engineering contractor, and they are characterized by many disciplines are working in the intertwined, very complex way, and there are many engineers involved. And what they are doing is a process which transforms requirements into partial solutions and new partial solutions, and you want to capture these solutions and make those part of the description of the facility. This is the project. So ontology engineering tools, I would say basically you treat type as a class, and you use classes to classify. And in a DL context, you will talk about the T-box and essentially link ontology to the T-box. Whereas the picture I just showed is about systems, and systems will, in a description logic framework, be in the A box. They are objects. So where do the objects come from? This is an important part of this process, and should be addressed by ontology engineering tools. So we need from ontologies support for the process, which is the systems engineering process, as I just explained in brief. And it has to be simple, because I mean, a lot of disciplines, a lot of engineers, they can't possibly relate to usual ontology tools. I mean, no way. So what we need are really some precise structuring principles, and principles that can be understood and applied and still be supported by ontologies. And therefore we have introduced what we call the asset information modeling framework. And some key points there is that we create the objects through relations. And it also means that we have very tight control of the relations. And we use the relation also to designate or to name the objects. So for those who have, the traditional tag system in industry, what we do is essentially to make another such identification system. And this is sort of a view of a system. There is a system block. There are terminals which are connected to other terminals. So this is the system boundaries, and system interfaces will be these arrows, these relations. And there is a part-whole relation. But all these relations in the context of this engineering project are really steps that show choices made in the solution. So if you look at these figures, I mean the system block, for instance, you could have properties or types on those objects, and they will be interpreted as requirements for system performance or system specification. And those requirements are transformed into new requirements for the children. So the whole setup is really documentation of the engineering process and the important choices made. And classes in this context could be also, I mean, standards references, what are called typicals, design patterns, such things. When we have this simple pattern, this can be, our experience is that this can be understood. It reflects current practice well. But what is sort of also special to our approach is that we look to this standard called ISO IEC 81346, which is a standard for life cycle information, and it is based on a fundamental concept of aspects. You divide your system description into aspects, and an aspect is essentially a breakdown structure, where a breakdown structure is this part of relation. You can add as many aspects as you like, but there are three that are fundamental. That is the function aspect, which describes the system from the point of view of requirements to its function. The same with the location, describing the system from the space that it occupies, and the product, which is specification of how it's actually going to be built. And these relations across aspects are relations that point to something that has to be verified. There's a verification of some element of information, piece of information, against some other. And then that spans the relations and therefore also the objects. And now we can come with type and we can classify these objects. And we want to propagate requirements through this topology that I just showed you, and type hierarchies. And for this, we need ontologies. So this is where ontology come in. And now I'll look at a few screenshots. Yeah, this is this shows some objects that are created in two aspects. So pink is location and yellow is function. And the relationship we view here are a part of. So it's hierarchical view. And there are some choices on different kinds of systems that you can use to designate these objects. This is a library that is sort of under construction, and there are attributes specifically to the objects that are written at the bottom. Another view is this is the same part of the same, but now we have a topology view. Now we view it from the point of view of terminals and how systems are connected to other systems through system interfaces. And some engineering disciplines it's natural to focus on a topology, and especially process, and others have more natural focus on the breakdown, on the functional breakdown, and the hierarchy. And it's important to be able to switch perspective. This is yet another way to. This is here we link across aspects. So information about the same system, but from different perspectives, and the linkage of these pieces of specification. And this is the start of a type editor where we build up types over this pattern by collecting properties. And this is it. That was my 10 minutes. So thank you.
Thank you very much, Arild, for your presentation and also for being aware of the time. So thank you again, and I'm trying to correlate with the other presentations because I think you might have something to comment with Enrico's presentation and the points for what is important for you to show in your system, in your visualization. But let's open first the floor to the attendees. If there are questions. Or hands raised? No, so far there are still no questions, I guess. We are all thinking how to pose them. So I was thinking about, so you really need to visualize what we call data, actually, rather than the ontologies, right? Or have some middle level. And I was thinking, do you think the points from Ben Shneiderman that Enrico's mentioned are enough for your use case, or would you need to extend those characteristics? Is there something more important for you to visualize the ontologies? I'm going to paste them in the chat because we don't remember all of them.
Yeah.
So if we need to develop the killer application for your use case, will we need to take into account something else?
No, but I see from that list, I think yes, all of that will be great. I think the point of visualization is not something that this project so far has reached to, because it's been so much focused on harvesting the knowledge and information. But it is going to grow big. It's going to be an RDF graph underneath that's going to be quite big. And I think the ability to focus on selected parts of it and will be critical. So I think zooming in and out is maybe the first thing to focus on, but maybe more interesting would be to specify a view through a query and investigate the model in that way. But I'm sure that when this project comes to these problems, they will be looking into the scientific literature on these points. Yes.
Thanks. So let's see if there are more questions from the audience. I don't want to monopolize.
I have a different question. I would like to answer questions in the
Ah,
chat.
Felix. Okay.
Sorry, yeah, it's me. Sorry. But I was not able. I sent personal messages because I did not see an opportunity to public answer questions in this tool here.
So, Felix, sorry, I didn't understand. Do you want to make a question? Ah, okay, sorry.
Well, yeah, I have a question. Yeah. And Enrico, sorry, can I go back to Enrico's as well? Yeah. Okay.
Yeah, I think we can now open the discussion to all the presentations.
Okay. I would just like a bit of curious of your opinion in the use of Neo4j for visualization of ontologies. I see. At least I don't have good solutions at hand, and I don't see them to visualize SCOS ontologies. And I would like to. I have the feeling that Neo4j could be a solution to, well, at least visualize SCOS in a very in a kind of intuitive and an easy way. Do you have an opinion to this? Or maybe, do you know Neo4j? This
No.
Sorry.
Hence, I have no opinion whatsoever.
Okay, no opinion. Okay.
It's written Neo4j.
Yes, Neo4j. Yes.
Yeah,
Okay,
no.
have a look.
Yeah, I'll have a look at it and we
Yeah,
can back offline.
Yeah, what you gave a developer showed me some work on this, and it looks quite promising for me. But
okay, yeah, no, it sounds interesting. Yeah, I mean, normally I'm prepared to have opinions also on things I have not seen, but I think in this case,
this one, so I got you. Yeah. Is there any tool for visualize SCOS ontologies?
Again, is a question for me. I not that I know of. I mean, in general, I mean, SCOS is not particularly complicated in terms of relation. Therefore, any good ontology engineering visualization or navigation tool should do. Clearly, as I mentioned, a lot of the complexity, but I think is also what Arild was talking about. It's ontology editors only seem to know about subclass superclass relations. So typically, when you have situations in which there are other types of things that you want to model, then I mean, not only in some cases there may be even problem with the underlying the representation language, but typically the UI is not geared for any browsing, any visualization which is not in terms of the main hierarchy. The good thing about scores is that it's not particularly rich ontology in terms of relations. So normally it should be possible to visualize it with current ontology engineering tools.
Yeah.
Although again, I think you raise a good point that you can have the best visualization tool in the universe, but at the end of the day, they're often domain-specific elements that you need to cover, and that also again what and again, I think it is what Arild was talking about. I mean, so often you have a project with a particular domain experts in a particular company, and they have a very specific need. And what we try to do is to sort of fit that need into the standard tools that we have. By standard tools that we have not been designed specifically for that need. They've been designed for people who want to build ontology. And then very often there is a gap. And it's not just I would say interface gap, but it's also a reasoning gap. For historical reasons, the semantic web community went down the description logic route. And that I would say, to say diplomatically, has advantages and disadvantages. There are certain things that you do very well with description logic. There are other things that are much more complicated, and of course, this is the fundamental trade-off in knowledge representation. You can't have everything, but sometimes you feel that some of the engineering choices are not the ones that you, I would say, face more. I would say more frequently in the application, in the word application. The word applications, the typical situation you face, a situation in which you have data, you want to impose constraints on this data, and you want to write reasoners about this data, for example, rules. That, if you start from a description logic framework, that's not necessarily the easiest thing to do. Although, again, the semantic web community has developed, a lot of other solutions to address this problem, but then these solutions don't necessarily come as a part of a standard package, which is reproduced in every single tool. So there is still a certain, interestingly enough, today, this year is the 20th anniversary of the semantic web, community. The Tim Berners-Lee paper and the first symposium were exactly 20 years ago. But funny enough, we are still in a bit of a flux with some of the elements of the infrastructure, which is just from a research point of view, but it's not brilliant for industrial people who just want solutions that work.
Absolutely, yeah.
So Felix just wanted to mention that you are getting some answers in the chat about systems.
Sorry?
There are some answers to your question about systems to visualize scores in the chat.
Okay. Oh, great. Yeah.
Keep track of the links.
Oh, thank you very much. Great.
In the meantime, we had a question for Arild. Can you say more about what Equinor will be releasing?
They will release an open source project on Git. It's a usual infrastructure and the documentation of the method, and I expect that it will then be possible to sign up and join the project. But essentially, it will be this model building editor and a type building editor. So that's on the schedule. On the schedule I've seen, it was scheduled for March, April, something like that, but that may change.
Thank you. And I think there are a couple of questions for Felix that we left before. Some of them are about the connections between the main tip, TS, and the two specific community ones. Are they connected, interoperable? And there is one related, like from Sanju, is there any interface to access ontologies and their entities? So
Yes,
those
okay.
are technological, go together.
Yeah, I think so. Yeah. So we actually have a base installation, a backend that holds the index of all ontologies that we manage, and this is our central installation, let's say, and then we have a front end project that that we can tailor on the need of specific communities. And so we have at this time we have three front ends, let's say, but they all are connected to our central backend and filter just those relevant ontologies for a community. So we use one backend but various front ends that allows some filtering. So this is the relation between the central instance and the community specific terminology services, and we provide a REST-based interface, to our service that allows you to automatically query our service, all the ontologies, all the concepts, definitions, and whatever you like, in an automated way. And we I can provide a link to it. We even have a good description and specification that you can use to play a bit around with it. Wait, just a second, please. Here. So this is a link to our Swagger website. I don't know where to post. I honestly am a bit overwhelmed with this human-computer interaction here.
Bottom
I put
right.
it here. There it is. It's a question now, but it's the answer to the question.
I will copy it.
Hopefully.
Okay, pasted it in the chat. Thank you. And and now there are two questions left that I think we can also merge. So Gerard Goldberg asks, how do you select the ontologies to be included? I also had a question about that related to the process to include the ontologies, so the selection and whether there is some curation behind that. And also Enrico asked about whether you will compare the concepts and the relations across the ontologies. So that could be also part of the process.
Okay. Yes. What ontologies do we include? They have to fulfill certain criteria, and this is first of all, they must have an open license so that we are allowed to process them, and that our users of the service can make use of them. We need a public available URL to access the ontologies, because otherwise we can't guarantee that our information that we present is up to date. So we index those ontologies on a regular time frame to have always the latest information available. And this is the selection criteria, and they have to fulfill certain quality criteria. As for instance, we pass them through several reasoners, and we have a bunch. We have a validation pipeline with various, like, let's say, quality metrics to ensure that these ontologies are, at least from this side, are working, or yes, are reasonable to include. And the last question was again
whether you map them.
Yes. Okay. Yes. Yeah. Actually, I think this is something very interesting that we would like to further investigate into, because putting all those ontologies together of a domain, it transports kind of a domain knowledge that is kind of spread across the single ontologies, and I think that is really interesting to find commonalities, to see how those ontologies interact, and to align those ontologies on such information. And I think this gives really valuable insights into how do you call them, ontologists, or whoever want to further work on their ontologies, would like to align them, would like to optimize to whatever criteria. And now with our service, I guess we are able to capture this community or domain, extra domain knowledge. And I think this is something that we really would like to further investigate and have and provide better insights into this through our service.
Yeah, Marìa, can I make a quick comment about this?
Please.
Of course.
Yeah. So yeah, no, in fact, these I think there are two really interesting elements, to your work beyond, the essentially the current service that you brought. So one element is that of landscape. There've been quite a number of studies about, what the landscape of ontologies looks like, etc. Of course, the moment you have a service that not only identifies and stores ontologies, but also has users. Of course, you can do a lot of interesting, they can provide a lot of interesting analytics about which ontologies seem to be more accessed, which, of course, it would be interesting then to have some ideas about what people do, once,
Sure.
is a bit more complicated.
Yeah.
But then the other thing also, what I found is, and again, we worked a little bit on this with Marìa a few years ago, is that, for example, when people build ontologies, at the moment, you can reuse entire ontologies. And also, for example, the work by Valentina Presutti, Alder, and Jamie on ontology patterns, you can also get, but very often, you simply have a relation. For example, you have, I don't know, start time. I was doing a few examples with you. So, start time, and you need, you need the start time, end time for something. You don't necessarily want to import an entire time ontology or even understand it.
Yeah.
So it's so useful to be able to go to your terminology server. Okay,
Yes.
say, has anybody defined something?
Yeah.
Like that?
Great. Yes, that's it. Yeah.
And but then you want to have like, okay, yeah, there are 3 definitions. But then if you can tell me maybe a little bit something about the difference.
Yeah. Yes. Yeah. That's exactly that. That's absolutely it. So you can drill down and have a look. Is this definition, does it met my expectation, and so forth, and or how does it relate with other concepts? And yes.
Okay. No, so certainly, yeah. I mean, and then if you're interested in the future collaboration, certainly that's something
Totally. Absolutely.
we'll have to discuss, because that's.
Yes.
I think that's still again, that's I would say still a little bit of a gap in the overall reuse of ontologies.
Yeah, because I actually see a huge problem that every project starts to work on a new ontology, and we are running from one isolated solution to the next. And I don't know if this is of any help. So we should kind of more reuse, we should integrate, we should align, and this is, I mean, otherwise I can't see how ontologies are a real help for us. I mean, that it should be a community effort, and the community should be able to collaborate, to be an active participant of it in whatever way. Yeah. Otherwise, there are so many ontologies on the market that have a quite short life cycle. Let's say, because after a project ends, they are not maintained.
So I don't know if it is my connection or Enrico's and Felix.
What specifically?
The connection was lost.
Oh, okay.
But only for Enrico and Felix on my side.
Okay.
So I don't know if that was the same for everyone.
No, we were okay. So I understand there's now a lunch break. So you provide lunch.
Okay, sorry.
Internet of Things.
Yeah. I had a question for you, Enrico, before that. Don't go so fast.
Okay, go ahead.
Okay, so I don't know whether it is me. So Christina, okay, so I think there is one question. No, I don't see the questions in the Q&A, but I might have been. Enrico, do you hear me?
Yeah, sure. Yep, I can hear you.
Okay, so I think my connection is very bad. So I don't know if there is a question. I don't see any question in the Q&A. Okay, my article is behind a paywall. I know there is an open version. I will send it. Enrico, I had a question for your presentation because now we are focusing in the last two. Do you have, or can you imagine a perfect or at least suitable enough or good enough metaphor for visualizing ontologies? That we have this desktop for our computers that simulate as a metaphor for our working desktop. What would be a nice metaphor for visualizing ontologies?
Ooh, that's a very tough question. Yeah, I mean, there've been some wacky ideas. I mean, for example, I think it was Bijan Pasha about 10, 15 years ago. He came up with these circle crops for visualizing ontologies, which was the most wacky metaphor I've ever seen for visualizing ontologies. But then we did an empirical study, and actually worked, which to everybody's surprise, users were able to sort of solve ontology engineering tasks with this metaphor quite well. So I don't know. I mean, I think in a sense, and just off the top of my head, I mean, there are two things. One thing is when you build the ontology, and by and large, you have things more or less under control if you're building your own ontology. The problem is really when you have to try and make sense of an ontology somebody else has built, especially somebody which is reasonably big, and then it's like really like a forest. So what if you go around the forest, not all the trees are the same. There are lots of different things, and at the moment, basically, our navigation does not allow for this diversity. So, for example, as I said, for example, with the key concept, we try to have metrics that say, well, these certain concepts tend to be more important, and we can identify them because, for example, if I have an ontology, as I say, about academic life, something like the concept of researcher is or the concept of academic is much more important than a specific concept like assistant technician. Yeah. So and that's correlates with the linguistic theories, with the theory of natural categories here. So I will imagine that exploration environments which take the metaphor of really navigating a complex urban landscape or a complex I would say forest where there are different things. So you have ways for orienteering between the different things. Could actually be an interesting experiment. Again, from a very brave PhD student to do that. Does that answer your question?
Yes, I didn't get all because I think my connection is being bad, but I think I got some important points and pointers you mentioned. So unless there is any burning question in the Q&A, I will otherwise thank again Enrico, Arild, and Felix for their time and their willingness to share their experience and knowledge with us. And now I will leave you for the deserved lunch, and just remind you that at 2:15 we have two other sessions, one in ontology adoption, which is quite related to the visualization if you want others to understand your ontology, and another one on ontology-based digital marketplace for industry commons. So you are welcome to any of them. And see you in the closing session at 4:25.
Okay.
See you.
Thank you.
Thanks.